Hi everyone. So today we're going to continue with our symbolic logic unit, and today we're specifically going to talk about logical equivalences as well as tautologies and contradictions. So let's first start with some definitions. So this is section 7.03, logical equivalence. So the first definition we're going to take a look at is a tautology. So this is a statement that is always true. And then the opposite of a tautology is a contradiction. And this is a statement that is always false. So we're going to use these definitions to determine if logical statements are tautologies, contradictions, or neither. And in order to do this, we're going to have to build a truth table for those statements and then see, okay, is that statement always true? Is it always false? Or is there some combination of true and false going on that would indicate that it's neither a tautology or a contradiction? So the first statement that we're going to take a look at is P implies P or Q. So to build this truth table like we did yesterday, we start with our P and Q statements. And then we'll need whatever's in parentheses, so P or Q. And then P implies P or Q, our final statement. So again, since we have two statements here, our first one's true, true, false, false, and then true, false, true, false. So our P or Q, so that is true when at least one of them is true. So we have true, 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 false. And then again, we have P implies Q. So we're going to take a look at this column here and this column here. And to refresh ourselves, implies is only false when we have true implies false. So taking a look at this, we have true implies true, so that is true. True implies true, that is also true. False implies true, that is true. And then false implies false, that is also true. So since this whole column is all true, this meets our definition of a tautology. So we can say that P implies P or Q is a tautology. Then let's take a look at another example here. So our second example, we can have the statements P and Q if and only if P. So again, we can start with our statements for P and Q. Let me divide this bottom one. So P, Q, and again, whatever's in parentheses, so P and Q, and then our final statement, and. So again, let's just start with our truth table. Sorry, that does say false at the bottom. And then we have true, false, true, false. And then so and is only true when both statements are true. So true, false, false, false. And now we're having this statement implies this statement. So this is biconditional, so technically order doesn't really matter. But when thinking about this, we're saying that we have true implies true. So we're doing it in this order. So again, this doesn't really matter, order doesn't matter here, but if we were doing a, or excuse me, I think I said implies before, that's for if-then. So if we were doing an implication, if we were doing an if-then statement, then order would definitely matter. So just take a note of that in the future. Order does matter, especially when you have an implication, an if-then statement. So here we have true if only if true, that is true. And then we have false if and only if true, that is false. So again, the rule for if and only if is they have to have this same truthhood in order to be true. So we have false if and only if false, that is true since they have the same truthhood. And then we have false if and only if false, so that is also true. So as you can see here, we were almost a tautology. However, we have this one false here. So this is neither a tautology or a contradiction. So now let's take a look at another statement so that we can see if we have a contradiction or a tautology in this next example. So we have P or Q if and only if P exclusive or not Q. So this is going to be a pretty big truth table just because we have a lot of quantities going on here. So again, we're just going to start with our P, Q, then we're going to do not Q, and then we're going to do P or Q, our first quantity, and then we're going to do our, excuse me, we're going to do this as exclusive or. So please amend that. This is P exclusive or Q if and only if P exclusive or not Q. So then we have P exclusive or not Q. And then our final statement, P exclusive or Q if and only if P exclusive or not Q. So building this truth table, again, we just start the same way. And so now we have not Q, so this is going to be false, true, false, true. And so for exclusive or, at least one has to be true, but not both. So if I'm doing P exclusive or Q, since I have true, true, that's going to be false. And then true, false is true because only one of them is true. And then we have false, true, so that is true. And then false, false, that is false. Then we have P exclusive or not Q. So now we're going to look at this column and this column. So we have true, false. So again, for exclusive or, only one can be true to be true. So true here. true, true, that is false. False, false, that is false. And then false, true, that is true. And then lastly, we have our final statement. So using these two columns here, and we're doing an implication, or why do I keep saying that? We're not doing implication. We're doing an if and only if, a biconditional statement. So they have to have the same truthhood in order for that to be true. So if we have false, true, that is false. True, false is false. True, false is false. And false, true is false. So this is a contradiction. So again, since we have all false here, this would be a contradiction. So now we're going to take a look at logical equivalence. So let's write our definition of logical equivalence. So two statements are logically equivalent if and only if, so this is a biconditional statement, their corresponding columns on their truth tables are identical. So meaning that if they have the same exact column, so if it goes true, true, false, false, and true, true, false, false, those match completely, so that's going to be logically equivalent. So let's take a look at an example to see if we have logical equivalence between these two statements. So the first statement we have P and Q or R, and P and Q or R. So are these statements going to be logically equivalent? Let's build their truth table to find out. So here we have three propositions going on. So our table is going to be a little bit larger than our previous ones. So we have P, Q, and R. And then our first quantity we have is P and Q. Then we can have our first statement P and Q or R. And then we have Q or R. And then our final, our second statement, P and quantity Q or R. So building the truth table, we should have 8 rows here. So the first 4 are going to be true for P. And the next 4 are going to be false. So I added a little extra that I didn't need. So then a quarter of these are true, so 2 are true, and then 2 are false. And then our last row, or excuse me, our last column, we just alternate. So true, false, and keep going. So then for P and Q, we want to look at the first two columns here, and then and is only true if both statements are true. So here we have true, true, false, false, false. And then we have false, true here, so that is also false. False, false is false, and then false, false is also false. So then lastly, to fill out this one, we're going to look at this here and this column here, and they're connected with or. So or is true if at least one of them is true. So here we have true or true, so that is true. False or true, that is true. I guess I should be saying it the other way since we have this statement first and then this statement. So false or true is true. False or false is false. False or true is true. False or false is false. False or true is true. And false or false is false. So now we're going to do Q or R. So these two columns here. So again, or is true when at least one of them is true. So true, 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 false. So we have true or true, so that is true. True, false is true. False, true is true. And then false, false is false. And so now on to our last column here. So we are going to use the P column and the column that we just created. And those are going to be connected by and. So and is only true if both of the statements are true. So we have true, true, so that is true. True, true is true. True, true is also true. True, false is false. False, true is false. False, let me use my highlighter. False, true is false. False, true is false. And false, false is false. So again, we're trying to see, are these two statements logically equivalent? So I need to take a look at this column here and this column here, and I need to see, are their columns exactly the same? Because if they are, then I have then those statements are logically equivalent. If they are not the same, then they're not logically equivalent. So if I have true, true, okay, those are the same. True, 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 false, false. We're doing great so far. However, we have true here and false here. So automatically, these two statements are not logically equivalent. And so these are the only statements that are different. So again, if it just needs at least one row to not be the same to make it not logically equivalent. So if these two rows were the same, then we would have logical equivalence. But since they are not the same, these statements are not logically equivalent. Okay, so please go ahead and complete the classwork, 7.03 Logical Equivalence, and then if you have any questions, meet me on Zoom at 1 o'clock. All right, have a great afternoon, everyone.